Hello, this is my second lab report. So the main purpose of this lab is to use charge tape and observing the interactions to find a difference between point charge interactions and interactions between evenly distributed charges across a line. So in lab 1, we represent tapes as single point charges, and this time we're representing them as line charges and splitting them into point charges. And the main physical principles and models are Coulomb's law, which is force is K times the two charges over R squared. There's also the electric field formula, which is KQ over R squared. And then force is equal to the charge times the electric field on the charge. And we also have Newton's second law, which is force is mass times acceleration. And also conservation of charge, so then you can't lose or gain any charge, the system. And opposite charges attract and same charges repel. And also the new idea of superposition, which means that we can sum up smaller E fields of smaller charges, and in order to obtain the E field of the bigger charge that makes up the entire thing. And so the preview of the results is this time the charge was different from lab 1, and it was instead 2.5 times 10 to the negative 8 coulombs, and the force of gravity was equal to the force of electricity, which was expected. And the model was, we treated the tapes as multiple small point charges lined up, all with equal charge, and we used superposition to obtain the total charge by adding up the E fields and forces. And main assumptions are ignoring air resistance, and that the tapes have the same charge, and the charges in the tapes are evenly distributed and separatable into segments of equal charge. Similar to lab 1, the system was the upper piece of tape, and the surroundings were the lower piece of tape and everything else. The main part of the experiment was to charge two pieces of tape, similar to lab 1, and just holding the lower piece of tape under the upper piece of tape and measuring the distance that the upper piece of tape elevated. And I got the same measurements as lab 1. I just used the same measurements, so the length was 0.205 meters. The width was 0.013 meters. The mass was the same, 0.000205 kilograms. And the distance between pieces of tape when the tape started floating was 0.024 meters. And for this coding model, this is the force of gravity is pointing down. The electric force is pointing up. There are two line charges. I split them into 100-point charges. And this going up is the E field. And I set it so initially I inputted my charge I calculated in lab 1, and then I found that the electric force and gravitational force were not equal, so then I tweaked it so that these forces would be approximately equal. The E field calculation is standard, so it's KQ over magnitude of R cubed times R, and then I split the charge into 100 I split the line into 100 charges, and then I just use superposition, so adding the small forces on each of these to find the net force. And the main difference between the models was lab 1 was not as accurate as lab 2. I'll discuss that later, but the division into segments yields a better estimate of the forces, and that the charge in lab 2 was around 2.2 times greater than the charge in lab 1. And main sources of error were charges of tape may not be completely equal or evenly distributed, and also human error, which involves incorrect measurements or accidentally touching the charge tape, which changes the charge. What if I had modeled each of the tapes as a single point charge, like in lab 1, and what were the differences? So in lab 1, we already found the charge was around 1.13 times 10 to the negative 8 coulombs, while in this one it was around 2.5 times 10 to the negative 8 coulombs. And so lab 2's charge was around 2.2 times greater. And these estimates differ because this lab's calculation had more precision because the line charge model splitting it into different smaller segments of charges, making it closer to the reality of molecules and atoms each exerting and experiencing force in an electric field is much better. So this lab result will be closer to real value. Thank you.